Towards the end, just remind me to talk about this platform code tantra on which you are going to write the exam. Okay, so let us first discuss our topic after that. Okay, so what has happened is that we have transportation problem was something like you had some places where things were available and then they have to be taken to some other places. Okay, there are availabilities and there are demands that has to be met. Total availability is total demand that is given, so that is why it is called a balanced transportation problem. And then each path of transportation, each path, each road, for each road there is a cost of per unit transportation, so that is Cij. And then your idea is to move all the availabilities to and like distribute, meet the demands, minimizing the total cost. So what we have realized that the matrix it is a matrix of like m plus, it has m plus n constraints, m plus n many rows, and then in mn variables. This is the transportation matrix or coefficient matrix or constraint matrix, whatever you say, constraint matrix. And it has rank m plus n minus 1, that we know. And then we also we can represent effectively this problem by something called a transportation array, which has m many rows and n number of columns, m rows and n columns. This is a table called transportation array. So the ijth element stands for the ijth variable. Okay, and then we realized, how do I recognize a basis? Now, in order to recognize whether a set of variables are linearly independent, well, if you want to see for that, the first result one proved is that, hello, anyone wants to ask anything? Okay, the first result one wanted to prove was that the basis matrix is lower triangular, which basically means in the basis matrix you will always find one row with exactly 1 1, and when you strike off that row and the column where that 1 is, you strike off those things, then again in the new matrix you will find another row, okay, with 1 1, exactly 1 1, and then you continue the same strike off and you will be able to cover that. A translation to that in the transportation array meant that if you highlight those variables for which you are taking the basis matrix, then you will find a line. In a transportation array, a line means either a row or a column. So you will find a line that has exactly one highlighted variable, and you strike that off, Again, you will find one more line with one highlighted unstruck variable. Okay. And you will be able to cover the whole table in this way, strike up the whole table. So that is a basis. Achha. So when you are striking up, for example, from the matrix, if you are striking up the rows and the columns, then you write it instead of, if you simply take the basis matrix and strike it up, then you would have struck up the whole thing. When I see, I wouldn't make out which one you strike, like which one you are striking up first. So better you write it as a sequence like R6 C4. That would mean that you first strike off the 6th row, and that had a single one at the 4th place. And then, so write it as a sequence. Similarly, for a table, if you are striking up, you write C3, R2, R3, C1, R1. It means first you have striked off from the table the column 3, then row 2, then row 3, then C1, then R1, like that you can write. So then I can understand which one is first, which one is second. In any case, as I said earlier, that with a little bit of graph theory, it looks much simpler. So what is that? Now suppose that you have look at this first figure, first table. Suppose that you have a selection of variables in this one. I have selected x11, x12, x21, x22, and x32. So for that, you can draw a bipartite graph. So for that, you can draw a bipartite graph. This is what kind of a transportation array? Now this is a 3x3 transportation array. Okay. Normally transportation array are like m by n, mn. Okay. So what you do, you take you put 3 vertices, call them a1, a2, a3, and 3 vertices here, call them b1, b2, b3. Okay. Since you have selected x11, x11 will stand for the edge from a1 to b1, x12 from a1 to b2, and then x21 will be from a2 to b1, x23 will be from a2 to b3, and x32 will be from a3 to b2. So that is how you draw a bipartite graph for a given set of variables. If some extra element is given x13, then you would have drawn a graph from a1 to b3. Okay. Similarly, here is another set of variable in the second one, x11, x12, x13, x21, x23. This is another set of 5 variables. You could have taken a set of 7 variables also. I mean, it is okay. Because it is a 3x3 matrix, if you take all the variables, then what you will get is K33, the complete graph, complete bipartite graph. Okay, K33, that you would have got. Doesn't matter. So this is how you draw a graph. Okay. The first proposition is that, so acha, if S is my set of variables, this is the set of variables, some set, okay, some set of variables, then the graph I denote by gamma S. This is this bipartite graph. Okay. So here is the first lemma. Suppose that I have a set of variables S, and suppose that you see that gamma S contains a cycle, then S is linearly dependent. What does it mean? It means that if you take their corresponding columns from the constraint matrix A, they will turn out to be linearly dependent. This one is easy. Say, suppose that you are looking at m by n. So assume that this is a bipartite graph. So assume that you have some cycle. There may be more edges. So this is like what? Now this is like I1, AI1, and this one is BJ1. I am not drawing there. There may be more vertices and edges. I am not drawing that. This is AI2. This is BJ2, and like this. This is AIK, and this is BJK. Okay, so what is the cycle? Now the cycle is this one, AI1, then BJ1, then AI2, then BJ2, dot dot dot, AIK, BJK, and then come back to AI1. This is the cycle. Okay, this is the cycle. I am talking about this cycle. Now, so what are the edges that you took? Now I took first XI1J1. That was the first one I took, XI1J1. Now XI1J1 corresponds to what column? Now the column would be of the form EI1 by EJ1. Then what? Then is XI2J1. Remember the variables, their first subscript is from left, second subscript is from right. So you do not write XJ1 I2, but you write XI2J1. Okay, and this one is of the form EI2 by EJ1. Now if you take minus, then this EJ1 cancelled. What is the next variable? The next variable is XI2J2. Now XI2J2. So that would look like EI2 by EJ2. This is not by, not division. So here there is a minus EI2, so you add this one. So then minus EI2 plus EI2, that will get cancelled. That will be 0. And you continue. After that, what is the final edge? And the final edge is EI1JK. So that is XI1JK, which is EI1 by EJK. And you would end up with a minus. Okay, not plus, but with a minus. You will end up with a minus. Why do you think you will end up with a minus? This is XI1JK. That is because it is a bipartite graph. Because it is a bipartite graph, any cycle will have even length only. So what is happening is that at the even positions, you will see at the odd position it is a plus, at the even position it is a minus. That is what. So okay, this is first one is plus, minus, plus, there is a minus here, and the last one is even position, it is a minus only. So if you do that, what you will get is 0. So if there is a cycle, if S contains some variables which constitute a cycle in gamma S, then their corresponding columns will be linearly dependent. Okay. Then you will ask like whether this is if and only if. Suppose I have a set of variables which, and I look at gamma S, their bipartite graph, and it does not contain a cycle. Will it be linearly independent? The answer is yes, it will be linearly independent. Okay. Okay, so for example, if I say so, like so that the columns of A corresponding to the set of variables, here what I have given, x11, x12, x21, x22, and x3 1 is linearly dependent. In what? Not some m by n, some 10 by 20 something, some big transportation this thing. So then what you can see that there is a cycle from where now first edge is from A1 to B2. So from A1 to B1. Then next one is, okay, and here there is like let me draw so that is better. What I have A1 to B1, and then A1 to B2. 1 2 is that, and then A2 to B1, and then A2 to B2, and then 3 to 1 is also there, but that is not necessary. So what is my cycle? Now I can see A1 B1 A2 B2 A1 is a cycle. So the corresponding edges will give the variables corresponding to those edges, those 4 edges. They like, if I look at their corresponding columns in A, that will be linearly dependent, as we have seen. Otherwise, like, you can simply write down their this thing. The problem is that you can try to write down their columns itself, and so that this plus minus this one, this is going to be 0. Okay, so I am talking about the converse. What is the converse? Now suppose I have a set of variables S, non-empty set, at least one variable is there, because if empty set you have given, then correspondingly I will be taking the empty set of columns. Empty set is always taken as linearly independent. Okay. Okay, so let S be a set of variables. When I say like this, S be a set of variables of the transportation problem. We are talking about this, nothing else. And suppose that gamma S does not contain a cycle. So if gamma S does not contain a cycle, will it have a degree 1 vertex? Degree 1 vertex, also called as pendant vertex. Okay. And the pendant edge is also called like the pendant edge or leaf. This is what? Degree 1 vertex. Will it have a degree 1 vertex? It does not have a cycle. Will it have a degree 1 vertex? The answer is yes.
Yes.
It has to have, because the first of all, it will have a vertex which has degree positive, because there is at least one variable. You stand at that vertex, because its degree is positive, you go to it has some adjacent vertex, you go there. And because you have assumed that it does, like suppose you assume there is no degree 1 vertex, so wherever you have reached, that has degree at least 2. That means you can go out again, and you can again go out, but the graph is finite. Because the graph has finitely many vertices, it has to repeat. So the first place it repeats, that gives you a cycle, and you have assumed that there is no cycle, so that will be a contradiction. Okay, so it will have a degree 1 vertex. So suppose that I have a degree 1 vertex. I remember gamma S looks like something like this. Okay, gamma S, there will be some edges somewhere, and I have a degree 1 vertex. It is a vertex from so it will be one of these vertices, like A1 to AM, B1 to Vn, one of them. You can select any one. Either you select from A side or B side, anything is the same. Argument is similar. Suppose that I found A I naught is degree 1. Okay, in where is degree 1? In. So suppose that A I naught is degree 1, that is pendant in gamma S. So I naught has degree 1, so it will be adjacent to somebody, whoever it is adjacent to, you call that Bj naught. Okay, so it is adjacent to somebody, it will be adjacent to only one because it is degree 1. So what do I have now? I have X I naught J naught belongs to the set. Otherwise, how will you have this edge? So this is the thing that belongs to the set. And what is the corresponding column of A? Now this is E I naught and E J naught. Now imagine any other line, any other variable Xij. Okay, any other Xij in S. Okay, take any other Xij in S. For whatever Xij in S, except this I naught J naught, you will not use I naught again, because the degree of AI naught was 1. It basically means I naught was used only once. For the rest of the Xij, whatever column Cij you will get, that EI on the top will not be the same as EI naught. Okay, so therefore this column Ci naught J naught, this column cannot belong to the span of the rest, because all of them, each of those Cij, okay, they do not have EI naught on the top. So at the I naught place they have a 0. So by taking a linear combination of them, you cannot generate 1 at the I naught place. So it follows that Ci naught J naught does not belong to the span of Cij, where Xij belongs to S and Xij, actually S minus S set minus X set minus Xi naught J naught. You remove X. So it basically means Xi naught J naught is independent of the remaining. Okay. Now what you do? Now you consider the same set, SDAX. You call this as SDAX. What is SDAX? Now S set minus Xi naught J naught. What is this? Is this a set of variables? Nah, this is a set of variables. If this is empty, then you are done, because your set was only having one element, so the corresponding set of columns will be linearly independent. So assume that it has more elements, so then in that case SDAX will be non-empty, no problem. But does gamma SDAX contain a cycle? No, it will not contain a cycle, because gamma S was not having a cycle and I have deleted one H. That will not create a cycle. Okay, so gamma SDAX will not have a cycle. And therefore, by induction, S dash is linearly independent. Induction on the size of S. So if you apply induction on the size of S, you are done. S dash is linearly independent. Now, why will S be linearly independent? Now, because X I naught J naught was not belonging to, that is C I naught J naught was not belonging to the span of these columns. So you have an independent set, and then you have another vector which does not belong to the span of this. Then the old set union the new vector, that element, that is also linearly independent. So using that. So what do you get from this? Now a set S of variables forms a basis if and only if gamma S is a tree. Wait a minute. I said S is like gamma S contains a cycle, means linearly dependent. Gamma S does not contain a cycle, means linearly independent. Now forms a basis. Now S is forming a basis means that you will have S will have m plus n minus 1 variables. Okay, because that is the rank, and that is the rank of the coefficient matrix. Okay, that will have that many variables. Oh, acha, in that case, gamma S will be a tree. Why? Now, gamma S is a graph on m plus n vertices. Remember, A1 to AM, B1 to Bn, these many vertices. And it does not have a cycle. And it has m plus n minus 1 edges. So it has to be a tree. The converse is also true. That is the same thing. So if it is a tree, then it will have m plus n minus 1 variables only. And it will be linearly independent. So it is a basis. Okay, m plus n vertices. Like one of the equivalent definitions of a tree. On n vertices, a graph on n vertices with n minus 1 edges, not containing a cycle. Okay, an acyclic graph on n vertices with n minus 1 edges. Okay, so here is a third test, and this test is more effective, and this is not just this graph theoretic condition is more useful. I will show later also. So how do you check given a set of variables is a basis or not? This one says just draw the graph. If it has a cycle, doesn't have a cycle, yes.
Hello.
Yes.
Sir, theorem 18.6, the size of S should be m plus n minus 1.
Size of S, yes, that many variables. That is what I have written over here.
Where? In the right side. Yeah. You mentioned it. Yeah.
Right, and then the number of vertices will be m plus n.
Yeah, so it is a tree. Yeah.
If I say S forms a basis, then it automatically means like it has size is m plus n minus 1, therefore gamma S will be a tree.
If we just see that statement, then it's mathematically incorrect, no?
No,
because
it is correct.
A set S of variable forms a basis if and only if gamma S is a tree.
No, suppose it forms a basis.
Okay. The second, if gamma S is a tree, then that implies m plus n minus 1 edges. Yeah.
And that implies, and from basis also. Basis implies m plus n minus 1 variables.
Yes, thank you.
Okay, no problem. And I mean, everybody, you please ask this type of doubts. I will be very happy. Okay, so some exercise, whether it is a basis or not. Basically, I mean, even you can do this in 3 different ways. You can check it. Okay, first by writing the basis, I mean by writing the corresponding submatrix of A, or you can do it by transportation array, check whether you are able to delete, I mean strike off the lines, or you can draw the corresponding graph, bipartite graph. Okay. Acha. Computing a basic solution for a given basis. So suppose that a basis is given. Earlier also, when we had a basis, we knew how to compute uh, its value. I mean, given x equal to b was given, and then I took, like suppose I take this as the basis, then how do I get the value? So that we did. Here also we can do the same thing. So suppose that we have been given a basis. Look at the examples. The description given above is basically that. Now, because it is a basis, in the strike-off process, okay, there will be a line of the transportation array that contains a single highlighted variable. So here there are many lines. For example, I can select row 3, or I can select row 2, which has a single highlighted variable, or I can select column 1, I can select column 2, or column 3. I cannot select column 4 because column 4 has 3 highlighted variables. So any of that you select, any one. So assume that you select C1. First I select C1. So the moment I am trying to strike off column 1, it basically means I am taking x11 equal to 150. Okay, because that equality has to be satisfied. Okay, and then suppose I am selecting column 2, then I am taking x12 is equal to 200. Suppose after that I am selecting row 3, then what am I doing? Now I am taking x34 equal to 300. So I have selected that. Next, you will still have a line containing one highlighted unstruck variable. Which one? Now suppose I select column 3. So column 3, in that case, x13 is equal to 250. Okay. So then what? Now then, of course, you have two variables in one single line. You strike off one single. Huh? So then what do you do? So, okay, what have I selected? I have selected column 3, so that is done. So then you will have two rows extra. So what will be x14? Now x14, the total sum has to be 200. I have selected 150 for it, and I have selected 200 for it, and I have selected 250 for it. And since now I am selecting this, the total sum has to be equal to 200. So therefore, x14 has to be minus 400. So this has to be minus 400. Okay. And then what? This value has been selected to 300. And then this total has to be, this has to be satisfied. Next I am selecting this one. This has to be satisfied. So this is 250. Okay. So that is how, and the non-basic variables are of course 0. So that is how you determine the values of the basic variables. non-basic variables are anyway 0. Otherwise, equivalently, you can do it using the tree also. First, you have to determine the values of the pendant vertices. Degree 1 vertex, do it, delete it, then continue. So that is how it is. So here I have done like that. So is it true that if I take an arbitrary basis and I mean compute the basic solution corresponding to this, will that give me, so I did not write x24, you can write x24 equal to 250. Achha, so will that give me a basic feasible solution? Now why? Like that is not necessary. Even in the general LPP also, when you have a basis, you will get a basic solution. It may be feasible, maybe inside the feasible set, maybe outside the feasible set. For example, this one we computed over here is a basic solution which is not feasible. It has a negative entry. Okay, so if that is the case, and what did I do earlier? I used simplex algorithm. But to use simplex algorithm, you will need a initial basic feasible solution. So how do I get a basic feasible solution? Now, getting a basic feasible solution is always easy. What you do, suppose you want to get a basic, write a basic feasible solution. Anyway, the general is that you have complete freedom. Select any variable of your choice. Suppose I select x23. Now you see, are you able to see this 18.11 example?
Yes, sir.
Right. So then see x23 if you select, then you look at the AIs and BJs that has been given. This is in the second row, so A2 is 120 and in the third column, so B3 is 70. Whatever is the minimum, you give that value 70. And so which one it matched, whatever it matched, because it matched this, you strike that up. That is gone, and modify this because 70 is gone to 50. So what do you have? Assume that you actually do not have this strike of this struck up column, you do not have. Then what do you have? Now I again have a new transportation array. Well, you know how to find a basis. Select any variable of your choice, whatever variable. I select, so basically repeat this process. I select x34. Now x34, 90, 20, 120, so I give 90. And then you strike this up. And this one modified to 30. Okay, then you select whatever you want. So in this way, you can continue. Finally, you might have to select few many. If everything is gone, finally, and you still need more variable, you can add one or two more variables by giving value zeros. Okay. If values become 0, this one is gone, this is totally gone, this is totally gone. Okay, so you can go randomly. For example, I give 90 over here, so that means a 10 remaining, so that this one also goes. Okay, because this is a 10 remaining, I give 10 to this one, so then this thing goes, and this one becomes 40. Okay, because this is 40 and this is 50, I give a 40 here, and now this one goes and this becomes 10. Now because this is 10, this fellow is single remaining, so that is, this one is gone, this is gone, and this is 30. That is fine, everything is matched. So what are the basic variables? Basic variables are this, wherever I have written the values 1, 2, 3, 4, 5, 6, 7. It is supposed to be 7. 5 plus 3 minus 1. Okay. So you can really go randomly as per your wish. So here in this example, I would have gone some other way. Okay, so you notice how we are going. And this initial BFS that I am saying, okay, this process will give me an initial BFS, and it will give me initial BFS. This algorithm, it will give me or give us a BFS correctly. Why? Now look, first you selected a square, that is a variable, and you striked off a column or a row for it. And the next variable was selected outside, not from the strike line. So this ensures that the set of variables that you are selecting are linearly independent because of the strikeout procedure. Okay, and at every step, the value of the variable that you are selecting is minimum of this ai dax bj dax, whatever is the modified ai dax bj dax, and they are always greater than equal to 0. So the values are also greater than equal to 0, values of the selected variables. What about the non-basic variable? And non-basic variable are anyway equal to 0, greater than, I mean, so this whole set of variables is linearly independent, and the values are greater than equal to 0. So that is a BFS only. Okay, so that is what the argument is. If you look at some old textbooks, so there are some traditional ways of selecting the initial BFS. One is the northwest rule. Northwest rule is like, I will tell this way, I will tell again. So let me so I will do it in the first one, huh? So that in the first one. So what it will do, so instead of selecting a variable randomly, it will first try to saturate x11. X11 will get saturated first, either by its row or by its column. Now if it gets saturated by its column, then you proceed to in the row. So starting from north, you go towards east. Then depending on that, so basically you always select whatever is the from the set of variables, available set of variables, you always prefer the northwest. So maybe you select something like this. So that way, or it will even come down like this. So always you are preferring to select the northwest variable of the available ones. That's the northwest rule. It's very simple to uh, apply here. For example, here it would have been 40 and 100, so I would have selected a 40 over there. The next one 50 was available, so 40, 50, 10. The next one is 60. That goes, so I can go right. Another 60, then 30, and then 90. I would have gone like this, the northwest. And the other one is the selecting variables. Try to favor the variables that has more, I mean the minimum cost. Okay. See, every variable means what? Variable means an edge and it has a cost of transportation. And what is your aim? Now my aim is to minimize the cost of transportation. Then select the cheapest edges na. So that is why. This is another. Nothing is guaranteed. Nobody says that if you select the cheapest edges, minimum cost, I mean variables, then your algorithm will terminate very quickly. That is not theoretically guaranteed. Okay. Okay. So these are two methods. I mean, two common rules, old rules. Okay. Sometimes somebody may ask, what is northwest rule or what is minimum cost rule? So that's it. Okay. The values of the variables in a BFS. Well, the best values of the basic variables in a BFS, you can always write them as summation of, okay, plus minus ai's plus minus bj's allowing repetition. Why is that? Now suppose that you are looking at a basis. Okay, so I am just looking at the transportation array. Select a basis. If you want to select a basis, let me select, okay, this one, this one, this one, this one, this one, this one, this one. Okay, because the northwest rule will go like this. Not only that, you can, I mean, this is set up 7 variables. You can, the strike off rule is always applicable. This last one to strike off, last column, last row. Again, I mean, the strike off procedure. Okay, so let me write down the strike off procedure also. This is a basis because of my strike off procedure. What is the strike off procedure? Now, first strike off C4. Then I can strike off row 4. Then I can strike off C3. Then I can strike off row 3. Then I can strike off row 2. Then C2. Then C1. Everything is trapped. Okay. Now, because of the strike off procedure, remember this is like, this is A1, this is A2, this is A3, this is A4, and this is B1, this is B2, this is B3, this is B4. Because of this, so the variable that I have selected, for example, I have selected this x44, the value of that variable will be equal to B4. This is where I start. So my statement is true. Induction statement is true. The first variable that I am going to strike off can be written as a sum of plus minus ai's and plus minus bj's. Here I am writing. If a column was struck off, then it was some bj. If a row was struck off, the first, then it was some ai. So it satisfies. Assume that you have determined up to, you have gone up to, so you have started with xi1 j1, that is the first one you struck off. Next is xi2 j2, that you determined by striking off some line, and you have gone up to xik jk. Okay, for that also you have struck off something. Now next you are considering xik plus 1 and jk plus 1. For that, some line was struck off. What line? Either it is a row or a column. So assume both of them are similar argument. Assume here that a row was struck off. That is, so so somewhere xik plus 1, jk plus 1 was available, and that row you struck off. So whatever row you struck off, did that have some, to begin with, some other highlighted variable? Now yes, it might have. It might have x I1 j1 or something, but those were they were already struck up. Those variables were already struck up. So in that row, so assume that line is a row. Is a row, and assume some variables, some of the already struck up variables were there in that row. Okay, so in that case, what will be the value of x ik plus 1 jk plus 1? Now the value of x ik plus 1 jk plus 1 would be how much? Now that would be x ik plus 1 jk plus 1. That value will be determined by a ik plus 1 minus whatever the variables of the struck up variables that are present in that row. But they are, according to you, each of them can be written as plus minus ai's and plus minus bj's. So in that case, in totality, you will have a combination of plus minus ai's plus minus bj's with repetition. It doesn't matter. So in that case, the total, like the form, the value of x ik plus 1 jk plus 1 also is having the same form. It is ultimately a combination of many plus minus ai's and many plus minus bj's. Okay, so by induction we are done. So had that been a column, it is the same thing. It would have satisfied, it would have been bjk plus 1 minus the already present variables, highlighted variables which have been struck up, their values. Okay, so that is how. There is nothing more. Why is this one important? And this one is a little bit more important actually because of its utility. What it says first, suppose you have been given that the ai is a1 a2 am, b1 b2 bn, they are all integers. Then it says that in a bfs the values of the variables will be integers, because the values of the variables will be a combination of plus minus ai's and plus minus bj's. In particular, if all the ai's and bj's are given to be 0 and 1, suppose they are given 1, not 0 1, just given 1, why would you keep a 0 row anyway? So yeah, suppose they are given 1. Okay, then what will happen? Now in a bfs, all the variables must have value greater than equal to 0. Fine. Because ai's and bj's are integers, in particular they are 1 actually, each of them. So in a bfs, the values of the variables, they will be integers. Okay, now the value of a basic variable cannot exceed the capacity ai1. If like value of variable cannot exceed its ai. Okay, because if it exceeds, then you will be forced to keep something negative in order to satisfy that equality. The equality will not be satisfied otherwise. So it will become basic solution, maybe not feasible, definitely not feasible. So in that case, if all the AI and BJ are given to be 1, then a basic feasible solution will have entries 0 or 1. It will have integers, it will have greater than equal to 0, that part is clear. It cannot have more than 1, that is also clear, because if the value of a variable is bigger than 1, then in order that the constraint is satisfied, some other variable has to be negative. Okay, so that is what it says, non-negative integer BFS. All AIs BJs are non-negative integer, then in any BFS, the values of the variables are non-negative integers. In particular, if all AI BJ are 1, then the value of any variable in that BFS is 0 or 1. Okay. So that is all. Acha, so I will stop here today. The minimality test I will talk next in the next class. Are you people? Do you people know how to give exam in Code Tantra or not?
This is the first time we are using also, sir.
So like in any course, if you have not done, then what I will do, I will post a video here how to use Code Tantra, and then tomorrow at let's say 5 we will have a mock test. Mock test means there will be no question, nothing. I will just make you attend the exam and then upload 1 or 2 pages of like photo, how to scan it, and then how to upload your exam. Okay, so tomorrow at 5:10, like 5 maybe, just after the class, maybe at 5. Do you have a class at from 5 to 6 or what?
No, sir.
Okay, so at from 5 to like from here for 5 minutes maybe, up to 5:10 or something. Okay, so what will be that? Now I will upload one paper containing some garbage, no problem. So that will be that you see whether you are able to access that. That is your question paper, and then you are supposed to take assume that some 2 pages, not 1 page, 2 pages of your rough note is your answer script. Then you use this Code Tantra to scan both of them and upload it as a PDF. So that practice we'll do tomorrow. Okay, and our exam will be on 23rd. That has been, I think you already know that. Okay.
Excuse me, sir.
Yeah.
Sir, I had a doubt.
Please ask.
In the gamma is it necessary to include all the AIs and NBJs even if they are not connected?
Yes.
Okay.
I am drawing that in the gamma is. So like if I have given you a 3x4 or 5x6 array, then that. I mean, what was your question basically?
Like even if suppose Xij is not there in our set S, then when we are drawing gamma S, should we include AI and BJ as blank points?
Yes, by definition, I am using that. By definition, I am using that. Okay, but like if I am going to ask you in the exam, I will be asking a 5x6 at the best, that kind of a thing. So it will not be a problem. But you, yeah, definitely put that as your vertex, single vertex, isolated vertex, if it is not used.
Yes, thank you, sir.
Huh. Like, actually, I did that, na? In that example. Wait a minute. Here, in the right hand side.
Yes, sir. I didn't pay much attention to it.
No, that is okay. You will anyway read this, na? And this is online, na? It goes very, I mean, there is a delay. lots of difficulties are there. If people are learning, that is very good. Like you are trying hard, that is fine. Any further doubt?
Not with me, sir.
So in the gamma S, all the vertices would be used, right? Like they would be
Yes.
connected.
I would. No, it will not be connected. It may not be connected.
But it's a tree, right? With m plus n minus 1.
If S, the variables in S,
basis.
give us a basis. I could have selected just one or two variables, then I would have seen a forest or something like that.
I meant to ask that only. Yeah.
True.
Also, sir, could you upload the notes before the lecture? Like, if we miss something, then we can go back and reference it. Like here, we don't have the control to scroll up or down.
Oh, acha. You are saying like, should I upload the clean version and then this version also? The clean version I can upload before the class. That is what you are saying.
Yeah.
Yeah. I can do that. Yes. I will do that from next class on. You should have requested me that. Anyway, I am using it. I could have easily done that. Yes, this is very good. Very good.
Thank you, sir.
Sir.
Yes.
Sir, given a BFS, is there a way like to follow and using the strike-off method, and we can arrive at that BFS?
Given a basis.
Like if we follow the strike-off method, then we arrive at a BFS, right? Like, but suppose an arbitrary BFS is given to me, then does there exist some method, like steps to follow which can help me?
This is the step only, na, the strikeout procedure, because it is given. Oh, you mean to say, suppose that you have given me the coordinates, the values only, not the basis. You have not told me the basis, but you have given me the physical point, like 15, 20, 0, 0, 0, 10.
I have given you the BFS also and the values of the points also. And then I am asking, like, can you give me the method of crossing out the columns and rows, the step in which order we have to cross so that we can arrive?
Wait. If you are saying that you have given me a BFS, giving a BFS means giving the point and mentioning the basis. If you are mentioning the basis, then you already have the strikeout procedure. Because that theorem says it is a basis if and only if the strikeout procedure. There is a line which has only one.
If and only if. Okay.
That is if and only if. Yes. Even this tree also, if and only. No, so your question, I can take it in a better way. Suppose that you have given me this much. Okay. What does it mean? Now, I had a 3x4 transportation array. Are you able to see this 15, 20, 0, 0? I have written. So suppose it means that I had a 3x4 transportation array. Fine. Let me write some 5 or something here so that ठीक है, छोड़ो जो भी है, whatever it is. So I had a 3x4 transportation array. Then what? Now somebody has given me a feasible solution. And then what I really see immediately from here, that okay, you remember the LPP thing, a solution, feasible solution is a BFS if the columns corresponding to the positive entries are linearly independent. So here, what are the positive entries? Now x11, then x12, then x21.
2.
Are they linearly independent? Now yes, linearly independent. BFS.
X22 now.
Oh, sorry, x22. Sorry. I have drawn the wrong one, not x. So are they linearly independent? Naha. According to our theorem,
It is a
a
tree.
set of variables is independent if and only if gamma s does not contain a cycle. So independent, yes. Or if you want to write down the columns itself, you will see these are independent. So if it is a feasible solution, then it is a BFS. Okay, so in that case, you will ask, sir, then what other variables to select? Because if I have to give a basis for it, I have to give m plus n minus 1 variables, na? Only then it will be a basis. Right now I have only got 3. So what did we do in our LPP case? Now you add any other variable keeping independency. So that means you put some other 0 values. Just make sure that you have a tree.
Yes. Yeah, I got it.
That will do. You can extend it in many ways and each of them will do.
Sir, I also had a doubt from the previous lecture.
Please ask.
Sir, in lectures, just let me open lecture 70. Hmm. In this, there was a proof where we had a matrix in which all columns had +1 and -1.
Mm-hmm.
At least
So
exactly
1
1
plus
plus
1
1, 1 minus
and
1,
1
and
minus.
also.
Others are 0. Yes.
Sir, why it is then why it is not a basis, like why it is linearly dependent, all the columns, given that all columns have this property?
Because in that case, row 1 plus row 2 plus row 3 plus row 4, if you take the sum of all these vectors, you will get 0, 0, 0. Na?
Okay.
And so that will be linearly dependent. Rows are linearly dependent.
Okay.
Right? It is a square matrix. Na? So columns are linearly independent if and only if rows are linearly independent if and only if rank is full.
Okay.
So if I show that the rows are linearly independent, then it cannot be invertible. If I show that the rows are dependent. And one way is to take a non-trivial linear combination of rows 1 times R1 plus 1 times R2 plus 1 times Rn is equal to 0. So I took a non-trivial linear combination of the rows and showed it to be 0. So rows are linearly dependent. It means rank is definitely less than n.
Yes.
Okay, so that is why you have to have a column in which only either 1 or -1 is there, but the other thing is not there. If you are claiming it is non-singular.
Yes. Got it, sir. Thank you.
Or shall I write an example?
No, sir, I got it.
Got it, na? Yeah, okay then. Anything else?
So, how does a basis imply? I can hear my voice. How
No,
does
I am able to hear.
how does a basis implies that there would be m plus n vertices exactly in the graph?
Oh, that one.
Yeah. Like to imply tree, we are asserting that there would be m plus n vertices in the graph.
A set of variables forms a basis. 18.6, na?
Yeah.
Are you able to see 18.6 now?
Yes.
On the screen? A set of variables forms a basis. Basis for what? For our transportation problem, na?
Yes.
So what is the transportation problem? Now our transportation problem is general m by n transportation problem. here M and N are, that is the transportation thing, na? So if it is going to be a basis, it will have to have a rank. I mean, it will have to have a basis matrix, will have to have M plus N minus 1 columns, na? You remember in the coefficient matrix, the constraint matrix A. Okay, so there were M rows and then N rows at the bottom. And we said a set of variables is a basis. In that case, the set of variables has to be M plus N minus 1 because the rank of A is M plus N minus 1.
Yeah.
Nah, because we are talking about the M by N transportation problem. So otherwise, if you wanted, I would have to write a set of variables forms a basis for the transportation problem, M by N transportation problem, for the M by N transportation problem. So basically, this is my understanding. When I am writing Mn, I am keeping it in mind that M is standing for the number of vertices on the left side and N is standing for the number of vertices on the right hand side. That is, M is the number of sources. That is our understanding. N is the number of sinks. And if you have to have a set of variables to form a basis, in fact, because rank of A, that is the first result. The rank of A, we proved that rank of A is M plus N minus 1. And therefore, if you have to select a set of columns, you have to select M plus N minus 1 columns and to form a basis matrix. So a set of variables will form a basis provided it has M plus N minus 1. So if somebody says, I have a set of variables and it is a basis for the M by N transportation problem, it basically means that person has M plus N minus 1 variables. Because for a transportation, M by N transportation problem, it has rank M plus N minus 1. Unless you have that many variables, you don't say you have a basis. And you have to have exactly that many and they have to be linearly independent. Their columns have to be linearly independent.
Like I thought that some vertices would be left out of the edges, but yeah,
No.
Yeah.
This is in the context of our MN transportation problem. Otherwise, you would ask what is M, na? Oh, acha. Here the context is, the total context is that for the, so I should have, maybe I said, if gamma, no, you don't leave out gamma S while you are drawing, you do not leave out any vertices.
Yeah.
Even if it is isolated, you keep it there. Okay, so I did not show the correct this thing because I said, okay, here it says, consider an M by N BTP. Put vertices A1 to AM, see, on the left and vertices B1 to Bn on the right. So that's how you draw the this thing. Okay.
Yes.
Yeah, like there will be a little bit of lack of understanding because we are like, this blackboard teaching has its positive. This one also, here one can go a little faster. On the blackboard I would have to write each and every word and it will go really slow, but there the understanding is better.
Excuse me, sir.
Yes.
Sir, what is the meaning of spanning subgraph? like gamma S is the spanning subgraph of previous graph. It's written.
Oh, spanning subgraph of the KMN. Spanning subgraph means it is a subgraph that has all the vertices.
Oh, okay. Okay.
So this KMN is the complete bipartite graph. Gamma S just has few edges, all the vertices and few edges. Just a spanning tree. Spanning tree of a graph basically means all the vertices and many edges are deleted. All what is remaining is a tree.
Oh, okay, okay, okay.
Hello, sir.
Yes.
Sir, I had a doubt in lecture 16 also. In there was a class example in which we have to bring the A3 comma. There is a matrix of suppose 10 cross 10, and we have to bring the A3 comma 5 to A1 comma 1 by
Right,
multiplying two permutation matrices P and Q.
Right.
And sir, I did not get how did you find P and Q over there? Like
Oh, yeah. वो आसान है.
how?
So are you seeing the matrix that I am writing? Suppose
Yes.
let me write 1, 2, 3, 4, 5, 6, 7, 8, 9, 5, 3, 4. Okay, you are seeing the matrix now.
Yes, sir. Yes.
Now I want to bring this 7 to the top left corner. So what there are two operations I will do. Two elementary operations. I am saying elementary. One will be elementary row operation and one will be elementary column operation. That means it has to go to the top row, and from third column it has to come to the first column.
So elementary row operation means I could multiply a matrix with it, and I will get the row transformation. But
and what will be the yes. What will be the elementary row operation over here? Now
R1
see
with R2 and R2 swapped, R1 and R2 getting swapped.
so it has to be 3 by 3 matrix, and so it will be 0, 1, 0, 1, 0, 0, and rest of them will remain like identity. So had it been more rows, everything identity?
How did you find this matrix? Like directly, how can you?
अरे वही तो लिखा था. First you have to take the identity matrix of 3 by 3. Then delete this capital E11. Delete this one. इसको 1 करो और इसको 1 करो. So ये हो गया 0, ये हो गया 0, बाकी ठीक.
Why are you doing that?
Because that is the elementary row operation, na? You multiply this, na? You multiply this matrix, what is the result? Now 0 times 1, 1 times 5, 0 times 9. You will have a 5 here. You will have 5, 6, 7, 8. And then 1, 2, 3, 4, 9, 5, 3, 4. You will have this matrix. Multiply. This is the elementary row operation corresponding to row interchange, na?
Okay, so if I want to swap R1, Ri and Rj, then I will just interchange Ei and Ej in the identity matrix.
Exactly.
Okay, fine.
And then do a similar thing for the column. For that you have to post multiply. Matlab multiply after.
So
and this has to 4 by 4 because you are multiplying from this side. So here what will be the matrix? Okay, let me erase this one and let me write down the 4 by 4 matrix. You tell me the 4 by 4 matrix. That will be better even. That yes. I am going.
So if I want to swap Ci and Cj, is it enough that I just swap Ei and Ej in the identity matrix in the post multiplication? Is that right?
Yes. That is correct. And so you tell me here, it is 1 and 3.
So I want to swap column C1 and C3. So instead of even I will write E3 001 001. You are doing in the row. Okay. Here I will write E2 E2 will be 0100 and 1000, 1000, and E4. Okay. 0001 0001.
Fine.
Okay. Thank you, sir. I got it completely.
Okay. And this is not the only way. For example, nobody told us to keep the third row in its place or the fifth row in its place. I can do there, changes. Like somebody says, you just bring 7 to the top position. And he has not said what you do with the other things. But this one is only 7 is coming to the top position. This is just one answer. It's okay.
Yes, I got it. Thank you, sir.
Anything else? Okay. If you do not have any other thing, then I will stop here.